Behind the ordinary objects which surround us in our day-to-day lives lies something extraordinary. Incredible stories of ingenious solutions to problems most of us never knew existed. So, what mysteries are concealed in everyday things we take for granted? Salt, running shoes, cargo ships, the wristwatch, and wind turbines. 5 ordinary things, 5 extraordinary stories, now revealed as we go behind the scenes, inside the machines to find out, how do they do it? We need it to live. We eat it every day. But where does salt come from? It's midday, but you wouldn't guess it because you're in an underground city. It has its own houses and shops, its own power supply, and a road system large enough for a small town. This subterranean metropolis even has its own petrol stations. The city, of course, is no city at all, but a vast salt mine buried deep beneath the plains of Ontario, Canada. This is the Sifto Salt Works. The plant churns out a staggering 25,000 tons of salt a day. These forklift drivers never stop. Demand is huge, and for good reason. We need salt every day just to survive. Our bodies must carry 250 grams of it to help maintain our blood supply. But salt, which is made up of 2 basic chemicals, sodium and chlorine, also has a vast number of commercial applications. Indeed, salt appears in over 14,000 different products, everything from paper to plastic, from cosmetics to chicken feed. And of course, in the brutal Canadian winters, salt stops ice forming on the roads. The most common source of this miracle crystal is a 400-million-year-old mineral known as rock salt. Thankfully, rock salt is plentiful, but to get it means going a long way down. At 600 meters underground, Goodrich is the deepest salt mine in the world. That's like Toronto's world-famous CN Tower pointing downwards. But Goodrich isn't just the deepest, it's also the biggest. These cavernous streets are the result of the way they dig the mine. It's known as the room and pillar method. As the salt is dug out, giant pillars of rock are left in place to support the roof. With such massive supports, tunnel collapse is pretty unlikely, but smaller rock falls are still a problem. So the miners deploy this. It's a metal dinosaur, and it's the biggest machine in the mine. It's called the descaler. Its job, to scrape away every gram of loose rock and debris until it's safe for mining to proceed. Five kilometers on, deeper into the mine, the ceiling drops to just 3.5 meters. Things are about to get tight. We're approaching the sharp end of the mining operation. It's called the cutter, a kind of giant mobile chainsaw. The cutter slices 3.5 meters into solid rock. The aim, to loosen a huge slab of salt and make it ready for blasting. Charges are laid. The area cleared. The excavators move in to push blasted fragments of rock towards what looks like a hungry hole in the ground. It is, in fact, the upper level of this giant juggernaut, a monster rock crusher. It could be a scene from Aliens, or perhaps Total Recall. The crusher mashes big lumps into smaller bite-sized chunks. It resembles moon rock. It's actually salt. Once crushed, the salt heads off into the gloom along an incredible 7 kilometers of conveyor on a journey that will take it through more stages of crushing and sifting, and eventually to the surface. This salt is now ready for dispatch, but it's industrial, far too coarse for human consumption. To get table salt, Sifto uses a different process altogether. Instead of sending people underground, Sifto sends water. These wells pump a high-pressure jet down 600 meters. The water hits the salt layer and comes back up to the surface as brine.
Yeah, it's very small and not much going on that you can see, but it is one of the most important parts of the plant. Without the brine wells, we really have no product. We have no raw material.
The brine ends up here in a place called the vacuum evaporation plant. It's a high-tech name for a relatively simple procedure. The brine passes through a series of huge vats, each one holding 20,000 litres, where it gets super steam clean under vacuum pressure. Eventually, the salt ends up here, a massive rotary dryer. The temperature is phenomenal, above 40 degrees centigrade. The dryer tumbles the salt until it turns from a gunk-like sludge into fine white powder, ready for the table. It's the end of the day and the end of another shift, but the machines carry on working deep underground. In the past 24 hours, Sifto has extracted another 25,000 tons of salt from its gigantic underground megalopolis. Five ordinary objects, 5 extraordinary stories. Coming up, they're cool, they're functional, they're worn by millions, yet they're also the product of space-age technology. The secrets behind running shoes next on How Do They Do It? Running shoes have got to be good. The average person takes 10,000 steps a day, which is almost 7 kilometers, depending on your stride. In your whole life, you can expect to have walked the equivalent of 4 times around the planet. During a marathon, runners will take 30,000 steps, each one creating a force of up to 4 times their body weight. Running shoes don't just reduce shock and impact. They're designed to prevent injury, improve balance, and can help you run faster, for longer. So when it comes to putting science into sports footwear, how do they do it? Japanese company ASICS are at the forefront of running shoe R&D. They produce 20 million pairs a year.
This part is carved too much. It needs to be filled in here.
Their research institute of sports science in Kobe is at the cutting edge of running shoe technology. Here, scientists and athletes work together to learn how biomechanics can be translated into the manufacture of a shoe. And their leading scientist is Dr. Tsuyoshi Nishiwaki, or Wacky to his friends.
This is the first running shoe the company made about 50 years ago, and it only had 5 parts.